Let's start with the concept of what a thermodynamic process really is. A thermodynamic process is basically a process where the three thermodynamic variables change measurably with time. So, since we are done with the concept of thermodynamic process, we can carry on with what thermodynamic variables really are. So what really are thermodynamic variables and what are actually the three thermodynamic variables? The idea of thermodynamic variables can be obtained from the ideal gas equation that we have learned, which is PV equals nRT, where P represents pressure, V represents volume, and T represents temperature. And these are the three thermodynamic variables. So in a thermodynamic process, one or all of these three thermodynamic variables tend to constantly keep changing. All right? Okay. So based on this, we have four types of thermodynamic processes, which are isobaric process, isochoric process, adiabatic process, isothermal process. So let's proceed with the idea of isobaric process first. What is an isobaric process? Well, an isobaric process is such a thermodynamic process where the pressure of the system remains constant. With that being said, we can say that the other two thermodynamic variables in the system keep on changing. An example of an isobaric process would be boiling water in an open vessel. Since the lid of the container or the cooker is open, the volume can change, and as you are supplying heat, the temperature is also changing, but the pressure remains constant. So this is an example of an isobaric process. Moving on, an isochoric process. Well, an isochoric process is such a thermodynamic process where the volume of the system remains constant. What can be the example of an isochoric process? Well, if you take that very cooker that you are dealing with in an isobaric process and close the lid of the cooker, then you have an isochoric process, since the water that is being turned into steam has no extra space for it to go and evaporate. And that is why the volume remains constant. Alright, moving on with a diabatic process. In an adiabatic process, the main feature is that none of the thermodynamic variables remain constant. In this type of a thermodynamic process, there is no transfer of heat as well. And from the first law of thermodynamics, we have come to know that dq is equal to du plus dw, which means that if you supply heat to a system, then a part of that supplied heat will be used by the system to do work, and the other part will be used by the system to change its internal energy. Over here, the term dq represents transfer of heat or supplied heat. And in adiabatic process, this dq is equal to 0. Now, we want to look for an example of an adiabatic process. What can it be? Well, if you have a cylinder that has walls that is made out of insulating materials, that does also have a movable piston, then you can say that there is no transfer of heat. And that is why this can be said to be an example of an adiabatic process. Alright, moving on with our last thermodynamic process. An isothermal process is such a thermodynamic process where the temperature remains constant. Well, an example of an isothermal process can be boiling water at constant temperature. Over here, the temperature remains constant since the reading in your thermometer gives the same reading over time, but the volume doesn't remain constant and neither does the pressure change with time. So we can say that this is a classic example of an isothermal process. So these are the 4 types of thermodynamic processes. Well, that's all.